Kandipa, sir. Yeah. Okay. Good morning to everyone. So today we'll look into three topics as we discussed last class in last class. So which will be those three topics will be calculus and differential equation. The second topic will be differential equations, and the third topic will be Laplace transforms. So first we'll go with the calculus part. So calculus, this remember this, like this is one of the most important topic, which will be also be used for your chemical engineering concepts. So for further derivations and also some solving equations, solving differential equations. So okay, so in calculus part around 22 questions, if I'm not wrong, you have. So just basics and all, like you'll just cover with the problems itself. So if you have any doubts, just ask me after the problem gets over. Each problem gets over, I'll give some few seconds time. Okay. Okay then. First, like we'll just start with the first problem. So what they have given us in the first question, if x is equal to a into theta plus sine theta, and y is equal to a into 1 minus cos theta, find dy by dx. Okay, so first, like we have taken the given, and we'll find with respect to, we'll differentiate x with respect to theta. Okay, so that similarly we'll also differentiate y with respect to theta, and when we divide dy by d theta by d by dx by d theta, we'll get dy by dx here. Okay, so that is our motto. So this is the problem how to start. Okay, this is the first step. So first we'll find dx by d theta. So we'll just differentiate the x is equal to a and a into theta plus sine theta. So when we differentiate, this theta is a constant term. So directly a will just come out, and differentiation of sine theta. So just multiply this a here. So again a is a constant, so it will come out. And now differentiation of sine theta with respect to theta is nothing but cos theta. So a into a plus a into cos theta. Similarly, dy by d theta. So multiply a to the both the terms. So what you'll get is again differentiation of constant term, which is nothing but 0. So again a differentiation of minus a into cos theta. So which will again a will just come out, and differentiation of minus cos theta will minus also will just come out, minus 1. So differentiation of cos theta is nothing but minus sine theta. So minus sine theta into minus a, which is nothing but a sine theta. So now we'll just divide those two, dy by d theta by dx by d theta. This is nothing but a sine theta by a into 1 plus cos theta. So a gets cancelled, sine theta by 1 plus cos theta. Now if you look into the options, we have the in the form of theta by 2. Okay, so we have to, it is not in a rational form, it is there in the direct value. So we have to convert the answer. So how can we convert the answer in theta by 2 terms? So what we can do is, so the sine theta can be written as 2 sine theta by 2 cos theta by 2. That is nothing but sine 2 theta is equal to 2 sine theta cos theta. So sine theta will be equal to 2 sine theta by 2 cos theta by 2 cos theta by 2. This is an identity. Again, similarly, so 1 plus cos theta. We know cos 2 theta is equal to 2 cos square theta minus 1. Okay. So cos 2 theta is equal to 2 cos square theta minus 1. So now we are writing cos theta. So which is nothing but divide by 2 in theta term. So cos theta is equal to 2 cos square theta by 2 minus 1. But here what we want is 1 plus cos theta. So take this 1 this side. So 1 plus cos theta is nothing but 2 cos square theta. So 2 sin theta by 2 cos theta by 2. So cos theta by 2 cancels. 1 cos theta by 2 cancels. 2 gets cancelled. So sin theta by 2 and cos theta by 2, which is nothing but tan theta by 2. That is dy by dx. That's all. Okay. This is the problem. Like I'll give you some 2 to 5 seconds. You can, if you have any doubts, you can just ask me. Okay. Okay. I hope everyone just understood this problem. We'll move on to the next problem. Okay. This is a volume problem of a cylindrical bucket. Okay. So what they have given, a liquid surface in the cylindrical bucket of radius r, which rotates in an axis, in its axis, and a parabolic profile. So given by the equation y is equal to a plus b r square. Okay, which is y is nothing but the height, and what they are asking, the radius, the radial radius is small r. Okay, and the density they are given as rho. Okay, they are asking mass of the liquid. So for the mass of the liquid is nothing but, so m is equal to volume into density. Okay, but we don't know volume, so we have to find volume for the changing term. So what we are doing is we have to find volume. So for finding volume, we don't have any term. So for finding volume directly, what we can do is volume is equal to, volume is equal to area into its height. Okay, so this is the basic concept we are going to use. So first, like we are taking this is a cylindrical profile here, cylindrical thing. Then this is a parabolic profile. So we are considering a strip which is dr, and the radius about its axis, the radius is inner radius is r, small r, and the outer radius is capital R, and the height which is y. Okay, so that is what thickness dr, inside radius small r, and the outside radius is r plus dr. Sorry. Okay. So the average height is a plus br square. So now, like we are going to find we want to find the area. Okay, for the cylindrical strip. So for the cylindrical strip, so we are considering the area, which is nothing but pi r square here. Okay, so pi r square. So first for the outside radius. So the outside radius will be, so pi into r plus dr square. Okay, so and minus inner thing, this part, so which is nothing but small r, so pi r square. Okay, so now just simplify. So r square plus dr square plus 2r dr minus r square, so r square gets cancelled and dr square will be 0 because dr is already a small term. So dr the whole square will be very small term, so it will be 0. So the remaining term will be pi into 2r dr. Okay, that is a term we have got here, which is area, which is nothing but area. Now we want volume, so multiplied by its height. So what is the height given here? A plus br square. Okay, so the volume, so we have got the volume here. So now you have to integrate between 0 to r. Okay, just to find the volume, okay, of the whole cross section. So we are integrating it to 0 to the r. So substitute y is equal to a plus br square. Okay, so when you substitute, this 2 pi will just come out because it is a constant, and just multiply this r inside this brackets. Okay, so we'll get ar plus br cube in terms of dr. Okay, integration in terms of dr. So when you integrate, a is going to be a constant. Okay, directly just take integration of x with respect to x will be x square by 2. So xn plus 1 by n plus 1. So we are writing here a r square by 2. Okay, so limits 0 to r. So 0 to r. So again similarly, so same thing, r cube we have. So power 4, 3 plus 1 by 3 plus 1. Okay, so b r plus r power 4 by 4. Same 0 to r limits. Okay, so when we substitute the limits, so r when we substitute it will be a r square by 2, and here also same r when we substitute it will be b r power 4 by 4. Okay, which is capital R. Okay, so now when we substitute 0, this total term will become 0. Same thing 0. That's all. So the volume which we get is 2 pi into a r square plus b r power 4 by 4. So this is the volume. Okay, so when you take r common. So now mass of the liquid. So into density. So into density will give you mass of the liquid. So this will be your answer. Okay. Okay, I'll give you some 2 to 5 seconds for asking your questions. If you have any doubts, you may ask. Okay, hope you guys are clear. We'll move on to the next problem. So, okay, volume of that. So this is a triple integration problem. This is one of the model which you can expect on the upcoming gates. So, okay, so now this is an easiest problem also. So we have 3 integrals. Okay, so when you take this 3 integrals, so the first integral will be corresponding to this first term, first differential term. So with respect to that, the second term will be differential with respect to this d5. The third integral will be d theta. Okay, so like this it will come. So this to this, this to this, and this to this. Okay, so now we have to integrate each part. So when you integrate the first term, so here we are with respect to dr you are integrating. So the sine phi will stay as it is. So when you integrate r square, so it will become r cube by 3. So with limits 0 to 1. So 0 to 1. Just substitute that. So when you substitute that, you will get 0 will become this whole term 0. So 1 when you substitute, it will be 1 by 3. So that is a term here, 1 by 3 sine 5 by 3. That's what we got here. So then again now d5. Okay. So d5. So when you integrate this, so this integration of sine, which is nothing but minus cos. Okay. So minus cos phi by 3, it will stay as it is with limits 0 to pi by 3. Okay. So when you substitute pi by 3, what you'll get is cos pi by 3. Cos pi by 3 is nothing but cos 60. So cos 60 is nothing but 1 by 2. So 1 by 2 we have got it here. Then 0. When you substitute 0, cos 0, which is nothing but 1. So 1 by 2 minus 1, which is nothing but minus 1 by 2. So minus into minus plus. So what we get is 1 by 6. So we have taken it outside since it is a constant. So now the left out term is d theta. So integrate with respect to d theta. So when you integrate, there is no term, only one constant term is there, only one. Okay. So when you integrate that, so it will be theta. So 1 by 6 theta 0 to pi are the limits. Okay. So 2 pi minus 0. So directly 2 pi by 6. So which will give you, sorry, 2 pi by 6, which will give you pi by 3. That's all. So the value of the integral will be pi by 3. Okay. Okay, I'll give you some 2 seconds for this question. If you have any doubts, you can just ask me. Okay, then we'll move on to the next problem. Okay. Now this is some common question. This is also some common question. So which can be asked in different terms. So this is the thing. So y is equal to x plus root of x plus root of x plus root of and so on infinity. They'll give us a function and we have to find y of 2. So first we have to find the function. So what we are taking is just take this x this side. Okay. So what you'll get? So y minus x is equal to same like root x root x plus root x whole plus root x and so on infinity. Okay. Now what we do is squaring on both sides. So when we do squaring on both sides, this y minus x whole square it will become. Then the square root and the square term will get cancelled. So what we get x plus square root x plus square root and so on till infinity. What is this term they have given in the question? This is nothing but y. So y here directly this term will equal to just y. So take this y this side and just solve for y. So when you just solve for y, what you will get is y square plus x square plus 2xy minus y. Okay. So when you substitute x, what they are given, y of x is equal to what is the thing? So x they have given it as 2. So when you substitute 2 here in terms of x, so y square plus 4 plus 4y minus y. So what do you get? So just a minute. So we get y square plus 3y plus 4 equal to 0. On factorizing this, what do you get? Y minus 1 and y minus 4 is equal to 0. So from this, what we get? So y is equal to 1 or 4. So this will be your option. Okay. So hope you guys understand. You can ask, like, just feel free to ask any
Uh,
doubt. Yes.
a minus b the whole square equal to a square plus b square minus 2ab, right? But you are putting
Yeah.
plus
Just
here.
a minute. Yeah, just a minute. Yes. There is a mistake over there. Wait. Mm. Yes. There's a mistake over there. Thanks for just correcting me. Yes. Now I guess it will be correct. It will be y square plus 5y. Yeah, now it is correct. The factorization. Okay. Okay, guys. Okay, then we'll move on to the next question. What is this? Okay, the function y is equal to this is based on differentiability and differentiable and continuous. So function y is equal to mod of 2 minus 3x. Okay, so when a function is said to be continuous, so what is the thing is like the limit. So the limit x tends to, let us keep y minus So f of y should be equal to limit x tends to y. F of y should be equal to limit x tends to y plus f of y. Okay, these all should be equal. Okay, so when these all are said to be equal, then the function is said to be continuous. Okay, so that is what we have got here. So the function what we got here is mod of 2 minus 3x. Okay, so when we take mod of 2 minus 3x, so at y is equal to 0, so what we get, x is equal to 2 by 3. So at that particular value of x, the all three before, like 2 by 3 minus, that is before, just before the 2 by 3 term, and also 2 by 3 at 2 by 3, and just after the 2 by 3. Okay, so when you take all these terms, like all these, we will get 0. Okay, it will the limit will be tending to 0. Okay, so when these all are equal, then the function y of x, this is the y of x, is said to be continuous for all x, x belongs to R. Okay, now we'll go for the differentiable term. Okay, so y of x is equal to mod of 2 minus 3x. Okay, so f of x is, when f of x is equal to mod x, the f dash x will be either mod x by x or x by mod x. Okay, this is a different formula, you have to just remember. So mod x by x or x by mod x. So at this, in this case, y dash x is equal to 2 minus mod of 2 minus 3x by 2 minus 3x into minus 3, because you have to again chain rule, you have to again differentiate this term, so which is nothing but minus 3. So when you differentiate that, so in this term, for if you see, like this term denominator can't be 0. Okay, so when it will be 0, so when x is equal to 2 by 3, so 3 gets cancelled, 2 minus 2 is equal to 0. So it can't be 0. So at that point, the value of y dash x will be infinity, which is not defined. Okay, so the function f of x is continuous and differentiable for all x belongs to R, except value x is equal to 2 by 3. Okay, because at x is equal to 2 by 3, the value becomes not defined. It is not differentiable at x is equal to 2 by 3. Okay, so therefore the option will be this. Okay, hope you guys understand. Just you can just ask me questions if you have any doubts in another 2 to 3 seconds. Okay, then I hope you guys are clear. We'll move on to the next question. So moving on to limits. Okay, so limit, so the value of limit, so limit extends to pi by 2 cos x by x minus pi by 2 the whole cube. Okay, so first, like, let us directly substitute this pi by 2 in terms of x here. So what you get, cos pi by 2, cos 90, which is nothing but 0. Similarly, pi by 2 in denominator will give you 0. So which is there in 0 by 0 form. So when you have a 0 by 0 or infinity by infinity form, then we should use L'Hospital rule. Okay, this is a rule. So what you will do in L'Hospital rule is, you have to differentiate the numerator term separately and differentiate the denominator term separately. So which is nothing but, so when you differentiate the numerator term, you'll get minus sin x. And when you differentiate the denominator term, we will get 3 into this x minus term, some term. Okay, so x minus pi by 2 the whole square. Okay, again chain rule, differentiation of x, you will get 1. So directly write this. So when you substitute, now you substitute pi by 2. So this term you will get minus 1. So when you substitute denominator, it will be 0. So now it is minus infinity directly. That's all. So directly minus infinity will be your answer here. Okay. Hope you guys just understand this problem. If you have any doubts, you can just ask me.
0 by 0 and infinity by infinity or whatever.
Yes, sir. 0 by 0 and infinity by infinity, it should not come. So like that is not defined actually. That is an regular form. So when you have that type of forms in limits, so you have to directly apply L'Hospital rule. So that is the thing.
Even though on applying L'Hospital rule, even getting infinity or some
No, yeah, we see that
infinity.
is what. So when we get here directly minus 1 by 0. Okay, no, we don't have 0 by 0 nor infinity by infinity. Even though if you get infinity, it is not a problem. But these 0 by 0 or infinity by infinity is an undefined form. Okay, So these forms you should not get, but you can directly, when you get directly minus infinity like this, minus 1 by 0, it is okay.
Okay, thanks.
You can again do that as well.
No, we can't. No, this will be the final answer, sir.
No, sometimes the thing is, if it is again, say first differentiation is coming like 0 by 0.
Yes, sir.
Second again, we can do that.
Yes. Well, see, that's correct. So sir has asked me the question. When you have, see, now we have differentiated the first term minus sin x 3 x minus pi by 2 the whole square. Okay. So now we have got so directly it is not in the form of 0 by 0 or infinity by infinity. Okay. So now again, if so, sir is asking again the form is 0 by 0 or infinity by infinity, even after differentiating the first time. So again, just apply the same rule until you get any other form. Okay, so that like you get solved and get the final answer. That's all. Okay, I hope you guys are clear. We'll move on to the next question. So okay, limit of sin x by x. So sin x by x. So sin x, everyone must have known the sin x range is nothing but -1 to 1. Okay, so that is what we have taken here. So when it is -1 to 1, what they have asked, limit of x tends to infinity sin x by x. So we have to find sin x by x range. Okay, so just divide by x on each and every term. So -1 by x, which is less than or equal to sin x by x, which is less than or equal to 1 by x. Okay, now what they are asking, x tends to infinity. So when you substitute x tends to infinity here, -1 by infinity is nothing but 0. Same 1 by infinity, which is nothing but 0. So directly the value will be sin x by x value when x tends to infinity will be 0. That's all. Is that clear? If you have any doubts, you can just ask me. I'll give you some 5 seconds. Same problem you can just do for other trigonometric terms also. For example, cos x, tan x, or anything. Okay. So for example, you may ask me. So you can, for example, let us take sin x by x. The x tends to 0 here. I'll just give you an example here. Sin x by x, limit x tends to 0 here. Okay. So now when we substitute x tends to 0 here, it will be sin 0 by 0, which is now in the 0 by 0 form. Okay. So what we can do? So again, L'Hospital. So just do for L'Hospital. So limit x tends to infinity. So when we do L'Hospital, you'll get cos x in the numerator. Denominator will be 1. Sorry, not infinity. It is 0. So when we do L'Hospital here, it will be 1 because cos 0 is 1. That's all. So this is an example for last problem.
Sir, tan function also varies between -1 to 1.
No, tan function doesn't vary. Only sine and cos, like the ranges are like -1 to 1.
You said you just try for other trigonometric function
Yeah, try
also.
for other trigonometric functions, but not, see, each and every function has its different range. Okay. So like you have to just check with its range and you have to just solve. You have a problem for tan x and tan x by x, if I'm not wrong, in the gate objective type. Just solve that and just ask me if you have any doubts. Just try solving this in your own.
Okay, okay.
Sure. Okay, then we'll move on to the next problem. Then limit of an integral. Okay, limit. We are going to do limits for an integral. So what they have given, limit x tends to 0. Sorry, just a minute. So limit x tends to 0. Integral term of 0 to z of x 2t by x with respect to dt. So now what we will do is we'll solve this integral, then we will apply limits. Okay, so that is why they have given this constant terms and all just for solving. So this is the question we have got. So when we solve this, so directly with respect to t, so x will be a constant term, it will just come out. Yeah, okay, x will be a constant term, it will just come out. So t term, so integration of t, which is nothing but t square by 2. So this 2 just will just cancel, 2 just cancels. Then t square by x. So when you substitute the limits, so when you substitute 0, it will automatically, this whole term will become 0. So directly substitute g of x. So when you substitute g of x, g of x the whole square by x. So when you substitute limit x tends to 0, g of x the whole square by x. So what you get? So when g of so x tends to 0, g of 0. What is g of 0? 0. So 0 by 0. So again 0 by 0 form. So again apply L'Hospital. So when you apply L'Hospital here, so remember it is a function. So when you apply L'Hospital, 2 into g of x you have done. Then again chain rule, g dash of x. Differentiate again the g of x. So 2g of x into g dash of x. So differentiate the denominator. So differentiation of x is nothing but 1. So now apply limits. So when you apply limits, we get what we get? 2g of 0 into g dash of 0. So which is nothing but, so g of 0 is nothing but 0. G dash of 0 is nothing but 2. So what we get? 2 into 0 into 2, which is nothing but 0. So the answer will be 0. Okay, is that clear? If you have any doubts, you can just ask me. Okay, I hope like you guys are clear. Okay, now let's move on to the maxima and minima of the function. Okay, so here the function they have given it as f of x is equal to 3x into x minus 2. Okay, so what for finding a maxima or minima, first what we'll do is find the first derivative of the function and find the critical points. Okay, so for what we are doing is, so find the critical point. So first derivative of this function will be 3x into x, which is nothing but 3x square minus 6x. Okay, so now differentiate this term. So when you differentiate this term, you'll get 6x minus 6. Okay, so now solve for x. So x will be equal to 1. So this x is equal to 1. So there might be one. See, we have only one value. So one critical point. So you'll have either one minima or one maxima. So to know whether it is a minima or maxima, you have two methods. Either you can just substitute this value in this question, sorry, in the function, and when you have two values and find which is the minima. Okay, which will be the lesser value, that will be the minima, but we have only one value here. So directly find the second double derivative of this function. When you find the double derivative of this function, so directly differentiation of 6 will be 0 and differentiation of 6x will be 6. So 6, when the double derivative of the function is greater than 0, you will have a minimum at that point. You will have a minimum for the critical point. When it is less than 0, you will have a maximum. Okay, so now when you have for this function you have greater than 0, so you'll have a minimum. So minima, so at x is equal to 1, you're having a minima here. So that is it. So that's all. If you have any doubts, you can just ask me. Okay, I hope you guys are clear. So let's move on to the next problem. Okay, now integrals. See, integrals are most important just to find in your chemical engineering concepts. So there are different methods to solve integrals. So like when you keep on just solve more and more problems, integrals, just you'll get grasp the idea of like how to start. See, for mathematics, it's for any question, let it be any problem, let it be mathematics or anything, how to start is very much important. So let us, so for this problem, so what you'll do is we'll find how to start. Okay, so based on this problem, the method for this will be shifting property method. Okay, so this property is nothing but, this is the question they have given, which is nothing but I is equal to root x by root x plus root of a minus x dx, a to 0 to a. Okay, so now we have to think of how to start. Okay, now what you can think is, so somehow you have to eliminate these if you eliminate, either we can eliminate this denominator term, so directly you can just solve this term root x. Okay, or what we can do is, somehow if we substitute or do any property method, you have to get a simpler version of this problem. So now we are doing a property method here. So what is a property method? So what we are using is using limits property, that is shifting property. Okay, so what we are using is f of x. So f of x is nothing but upper limit, so which is nothing but upper limit is a plus lower limit, which is nothing but 0, so which is 0 minus x, a plus b minus x. Say a and b are upper and lower limits. Okay, so f of x tends to a plus b minus x. So we are writing f a tends to 0, so 0 to a. Now we are writing x tends to, so this x is replaced by a plus 0 minus x, so which is nothing but a minus x. So we are replacing x by a minus root of a minus x, and this x is replaced by a minus x, and again same this a minus x is in here, x is replaced by a minus x, so you get root of x. So now what you got? So I is equal to root of a minus x by root of a minus x plus root x. Okay, this is an one more term after shifting property, same integral term. So by seeing these both, what you can tell? So when you add these both, both the numerator and denominator just gets cancelled out. So what you'll have remaining term, which will be 1. So directly integral of 1 will be x. So now that is the thing we have to think for how to start. So after how to start. So now we are just adding 1 and 2 equations. So you'll get I plus I, which is nothing but 2i. So equal to 0 to a root of a minus x plus x. So by root of a minus x plus root x. So just cancels. That's all. So what you get? 1. Integration of 1 is nothing but x. So again limits 0 to a. So 2i is equal to a. I is equal to a by 2. A by 2. So a by 2 will be your option. Okay. Is that clear? If you have any doubts, you can just ask me.
Can you explain that property again?
Yes. Okay, I'm explaining the property again. So I'll just write it here. So this is shifting property. Shifting property. Okay. What you can do is f of x can be written as f of a plus b minus x. So a plus b minus x, which is nothing but, so this is this limits a and b are limits of integral, and x will be now when you take this property, use this property, x should be replaced with the new x, so which is nothing but a plus b minus x. So that's what we have done it here. Okay, I hope you guys are clear. Okay. Okay, I'm moving on to the next problem. So now Lagrange's mean value theorem. Okay. So what they have asked us, given the function is f of x is equal to x cube plus 5 in the interval 1 to 4. So value rounded off, they're asking us to find the x. Okay. So now for how to start this problem is Lagrange's mean value theorem's formula. So from Lagrange's mean value, so f dash of x is nothing but f of b minus f of a by b minus a. B and a are intervals given here. Okay. So now f of x is equal to x cube plus 5. So a is equal to 1, b is equal to 4. Just substitute and find f of 1, f of 4. So you'll get 6 and 69. So just subtract f of 4 minus f of 1. Substitute all those values. So 69 minus 6 by 4 minus 1. So it is nothing but 21. Okay. Now what you know is, so f dash of c. So f dash of x is nothing but 3x square. So what do you know about f dash of c? So 3c square, which is equal to 21. So 21 gets cancelled 7 times. So c square will be 7 and c is equal to root 7. They have asked, since they have asked 2 decimal place, it will be 2.65. Okay. So c will be root of 7, 2.65, which is nothing but the value of x. So given here. Okay, is that okay? Like if you have any doubts, you can just ask me. Okay, I hope you guys are clear. We'll move on to the next problem. So, okay, now we are going to move for orthogonal property. Okay, for an functions, two functions, when two functions are said to be orthogonal, then the two functions will be, so f dash of function 1 and f dash of function 2, sorry. So f dash of function 2 will be -1, those two products. Okay, so from this what we have taken, so f dash of 1 will be equal to -1 by f dash of 2. So we have to find which curve here, which equation here is orthogonal to this function. Okay, so first let us find the f dash of 1 for this equation. So let us take xy is equal to c. So from this y is equal to, we get c by x. So that will be a function 1. So when you do differentiation for that, 1 by x differentiation is nothing but minus 1 by x square. So into c. So directly minus c by x square. So now instead of c, you can substitute xy. So x and x get 1 times x gets cancelled. You get f1 dash is equal to minus y by x. So which will be a function f dash for first function derivative. So from this, what you can do, find the f2 of this. So from by using this property. So substitute f1 here. So what you get? So just reverse of this, then minus minus gets plus. So xy, x by y. So f dash of f2 dash will be x by y. So now using this, when you differentiate these terms, which term contains f2 dash contains xy, x by y, that will be the curve which is orthogonal to xy is equal to c. Okay. So now we are going to solve from options. So when you take the first option, so taking it as y, what they have given, y is equal to c1 into x. So which will be function 2. So f2 dash will be equal to c1 is equal to y by x. Okay. So from this directly we get y by x. Why? Because like when you differentiate it here, so with respect to, just a minute. Yeah, with respect to x, so we get y by x. So substitute c1 here. So substitute c1 and just solve for it. And again, so take f2, which is nothing but function 2 for this term, c1 by x. So when you solve for c1 by x here, so f2 dash is equal to, differentiate with respect to x, we get minus 1 by x square. So again substitute c1 here. So when you substitute c1 here, which is nothing but you get y into x. So x gets cancelled, this x and that c1x gets cancelled. So you get minus y by x. But what we want f2 dash will be, it should be x by y. So moving on to the third option. So third option is nothing but take y square is equal to, so y square is equal to c1 minus x square. Okay. So that is what we are going here. So directly differentiate both the terms. So 2 into dy by dx minus 2x. Okay. So just don't take root of this term. You can just solve by that way also. But since this method will be easier, so when you differentiate like this, directly dy by dx is the term you want, and you know the value of y. So directly just substitute and no, you can just directly place that value here. So directly you just differentiate this term. So 2y into dy by dx with respect to x we are differentiating. This constant term will become 0. Then minus 2x. Okay, so this 2 and this 2 gets cancelled. So this will be f2 dash and this y just comes here. So minus x by y. That's all. Okay. So now this is not the option. So we need plus x by y. So the last option will be the answer. So y square, the term which we have is y square is equal to c1 plus x square. So again same way differentiating 2y into dy by dx, 2x into 2x, so equal to 2x, 2 gets cancelled, f2 dash will be xy. So the curve y square minus x square is equal to c1 is orthogonal to this curve. Okay. This is the question based on orthogonal property. Like if you have any doubts, you can just ask me. Okay, then I hope you guys are clear. Now we'll move on to the next problem. So this is Taylor series, another different topic. So Taylor series. So what they are asking is, coefficient of x square in the Taylor series of cos square x. So what we have to do is cos square x. We have to find write the Taylor series of cos x and find the coefficient of x square. Okay, about it 0. So Taylor series about x is equal to 0. This will be an expansion. F of x is equal to f of 0 plus x by 1 factorial into y dash of y dash 0, x square by 2 factorial y double dash of 0 and so on. Okay. So now this function x will be cos x. Okay. X is equal to cos x. So when you do x is equal to cos x, what they're asking the coefficient of x square. So coefficient of x square will be nothing but f double dash of 0 by 2 factorial. So that is the thing here we have written. So what they have f double dash of 0 by 2 factorial. So f double dash of 0 is nothing but, so 2 cos x, sorry, 1 minute. So f of x is equal to cos x. So x is cos x. So directly cos x differentiation. So double cos x. So first differentiation of cos x will give you sin x. Sorry, minus sin x. Again, sin x differentiation will give you minus cos x. So that is why we got minus cos 0 by 2. So cos 0 is nothing but 1. And here 2. Actually, you have a 2 here. Why? Because differentiation of cos square x to 2 cos square x. So that is the thing. That's all. So 2 gets cancelled, you get minus 1. So the option will be minus 1 here. Okay. Okay, then I hope you guys are clear with this question. Then move on to the next part of the next one more problem of Taylor series. Another model is exponential function. What they're asking is f of t is equal to e power minus t by tau, where t is small, very small than tau. Okay. So about t is equal to 0, this will be a Taylor series expansion as we saw in last problem. So now what you have to find, like directly we have to find, like substitute the values and just find f of t. So we know f of t is equal to minus t by tau here. So just substitute, like first find the first derivative of this function. So first derivative of the function will be, so directly e power x differentiation is e power x, so which is nothing but e power minus t by tau. Now again use the chain rule and differentiate this. So minus 1 by tau into t. So with respect to t. So directly minus 1 by tau comes out. So minus 1 by tau into e power minus t by tau. So that will be a first derivative. So when you substitute 0 here, so when you substitute 0 here for here, so because f dash of 0 we need, so directly this term becomes 1 e power 0. So we get minus 1 by tau. And when we double differentiate this term again, so when we double differentiate this, so what we get? So again the same value. What is this? So minus t by tau. So what is this? Where is this term? So again f double dash of this 1 by t, e power x differentiation is e power x. So minus t by tau. So when you substitute 0 here, so this value becomes 1. So it will become 1 by tau. Here last time we had minus, so minus into minus plus when we do double differentiation. That's all. Okay. So now this is the expansion we have got. Okay, actually just a minute. Here we get square, because here minus 1 by tau into 1 by tau we do. Okay, so when we do that, we get here, because the again we are differentiating this 1 minus 1 by t minus t by tau. So we get 1 by tau square. So just substitute those values here. Substitute those values in this equation. So we get 1 minus t by tau 1 factorial plus t square by tau square 2 factorial and so on. But this t square by tau square will be, so it will be 0. Why? Because they have given condition as t very less than tau. So this numerator part is very less than denominator. So this whole term will be approaching 0. So we are taking this, so the value will be only these two terms. So 1 minus t by tau, 1 factorial is nothing but 1. So directly 1 minus t by tau. This is the final answer. Okay. If you have any doubts, you can just ask me. Okay. I hope you guys are clear. We'll move on to the next problem. So this is exponential, the sum of derivatives of an exponential function. What they have given us, so y is equal to e power ax. Okay, so they have given the sum s is equal to dy by dx d plus d square by y by dx square and so on dn by dny by dx. Okay, so this is the function. What they are given, this approaches to y when n tends to infinity. Okay, so then find the value of a. which is nothing but this a. Okay. So first let us take y is equal to e power x. So dy by dx, what you'll get? A into e power x. So d square y by dx square. So what you get? Again differentiate this term. So e power x differentiation, e power ax. So again a power x differentiation will be a into a. So a square into e power ax. So similarly and so on till n, we get a power n into e power ax. Okay. So just now, so just substitute these values here in this equation. So when you substitute, s will be equal to a into e power ax plus a square into e power x plus a cube and so on, a power n into e power x. So now e power ax is the common term for each and every single term. So directly take e power ax common and take a also common. So what we get? 1 plus a square and so on till infinity. Why we are taking it as infinity? N tends to infinity, the s value will become 2y. Okay. So directly, so 2y. So sum of n terms in this term is in GP 1a square. So sum of square so this infinite terms in GP is nothing but a by 1 minus r. This is the formula for that. So a is nothing but the first term, which is 1. Then r, which is nothing but the common ratio, a by 1. So that is nothing but a. So r will be common ratio will be a. So directly 2y is equal to a into e power ax into 1 minus a. Okay. So directly when you do that, 2y, so y what we have e power ax. So just write e power x, e power x, e power x gets cancelled. Then 2 is equal, so from this find a. So from when we find a, we get 2 by 3. So here this is the option. Okay, is that clear? If you have any doubts, you can just ask me. Okay. I hope you guys are clear. See, there are several problems for if I'm not wrong, there are totally 5 to 6 problems for Taylor series. So like we have solved some 2 different models of Taylor series. So I hope like you should solve other Taylor series models or just to make use of them to just practice them. Okay. So now this is the question. So line integral of unit circle. Okay. So what they have given? So integral C y by x square plus y square or dx y by x square plus y square dy. Okay. So where C is the unit circle. Okay. So now for this, how to start? So just see, either you have to think like now when you differentiate, when you add these terms, sum up these terms, either this numerator and denominator should get cancelled. But here this is not x square and y square, and there are different differential terms here. So that is not possible, and we don't have any particular limits. So that is also not possible. So shifting property is also not possible. So now we go with substitution method. So what we do is when we take x is equal to cos theta and y is equal to sin theta. So since it is a unit circle, the theta will belong to 0 to 2 pi. So the limits will be 0 to 2 pi. So when you take x is equal to cos theta and y is equal to sin theta, so sin theta, so when you substitute here, sin theta by cos square theta plus sin square theta, d cos theta because dx. Okay. Similarly, minus cos theta by cos square theta plus sin square theta, d sin theta. Okay. Because y is equal to sin theta. Now what we should do is d cos theta is nothing but differentiation of cos theta is nothing but minus sin theta. So minus sin theta into sin theta, which is nothing but minus sin square theta. And here so d cos theta, when you differentiate d cos theta, you'll get d theta here. So d theta, and here cos theta by cos square theta plus sin square theta. So again d sin theta. When you differentiate d sin theta, what do you get? Cos theta into d theta. So cos square theta. So directly cos square theta. So when you now you can add. So here because we have d theta terms here. So now when we add, so directly take minus here. We have minus 1 here. Here minus 1 here. So take minus common. Denominator we have sin square theta cos square theta. So again that will be also 1, or just cancel out these 2 terms. So what do we have? Minus 1. So sin square theta plus cos square theta will be 1. So minus 1. So integration of minus 1 will be minus theta here because we are integrating with respect to theta. So limits are 0 to 2 pi. So 0 to 2 pi. So when you substitute the limits, you'll get minus 2 pi. I is equal to minus 2 pi. That will be your answer. Is that clear? If you have any doubts, you can just ask me.
You took substitution method like x is equal to cos theta and y is equal to sin theta based
Yes.
on the options, right? Because you
No,
can't choose
yeah, okay.
randomly.
Actually, you can go for the based on options also. That is one more method. But you can also think like when you have like an x square term plus y square term, when you take sine and cos theta, so sine square theta plus cos square theta will be 1, right? So this
Yes.
denominator term gets solved, right? So you can think in that way also.
Okay.
Okay. There's one more substitution method problem. So we'll move on to the next problem. So now this integration with respect to an exponential. Okay. So there, what is the question is integral dx by e power x minus 1. So now this limits are not given, so shifting property won't come. So now what something you have when you substitute in x, you can't solve this integral totally. So that also won't come. So but now what we can do is when we take this e power x term, okay, we have now what we are taking is this is on one more method. This is substitution method. This can be named as substitution method or eliminating method. So what we are doing is take this e power x term outside, okay, such that so when you take e power x term outside, you will get 1 minus 1 by e power x, okay. So now what we can do is so this take this 1 minus 1 by e power x term as y, okay. So when you differentiate this y, what you get dy by dx is equal to differential term of 1 is 0, and when you differentiate this, you will get e power minus again 1 minus 1 and minus 1 e power x. So minus into minus plus. So 1 by e power x, that is the term we get. So now what you do is take this dx term here. So what you'll get dy is equal to dx by e power x, okay. So dx by e power x. So what you have here? So when this term can be taken as dy and this you have taken it as y. So dy by y. Now what you can do, you have changed the differential term and also you have did substitution method here. So when you integrate this 1 by y, integral this ln y plus c and ln of 1. So now just y is equal to 1 minus 1 by e power x. So just substitute that. So this can be written as ln of 1 minus e power minus x plus c. This will be your option. Okay. You may ask me like why I have taken e power x common and just took 1 minus 1 by e power x term as y. So let us take in this case like you guys take 1 e power x minus 1 is equal to y, okay. When you do that, so again when you differentiate, so what you get dy is equal to dy by dx is equal to e power x, okay. So again when you multiply so for when you solve dy is equal to dx into e power x, okay. So when you do this, so what you have to do is so where's the integral term, so here, so here you have to have an product of an e power x term. So for that you have to multiply it on both sides again. So now you can take it as take this as dy, okay. Now this will be y and again e power x, so which is of no use. So this e power x again you can take it as y plus 1, okay. So this is another method. So dy, so now you'll have the term as integral dy by y into y plus 1, okay. So now you can solve another method is I'll just solve below this question here. So what I have done is this is the question b x by e power x minus 1. So for this e power x minus 1 is equal to y. So differentiation, so dy by dx, so dy is equal to dx into e power x, okay. So now multiply with e power x in both denominators and numerators. So when you multiply, Now this dx into e power x whole term, sorry, this whole term will become y. So when you do that, so integral dy by this e power x minus 1 will be y into what y is equal. So from that e power x will be equal to 1 plus y. So 1 plus y. So this will be our integration. Now again what we can do. So just we have to use partial fractions. This is one more method. Okay. So what is the thing is you have to separate these two fractions. Okay. We have to separate this 1 by y, this 1 by y term and 1 by 1 plus y term. So how you can do is, so when you do dy, sorry, let this dy be the same. So when you do 1 by y minus 1 by 1 plus I, 1 plus y into dy. Okay. So now just check with this. When you solve this, what do you get? So 1 minus y. So 1 by y. I am just splitting this term. So what do you get? 1 plus y minus y by y into 1 plus y. So this y gets cancelled. You get this term, y into 1 plus y. So this is nothing but this term. So I have just split this term. This method is known as partial fractions method. Okay, so that is how this term we have got. So after this, you have to integrate separately. Yes, you have to integrate this term separately. So integration of y will become ln y. So again, integration of 1 by 1 plus y will become ln of 1 plus y. Okay, so from this, we can write it as ln of y by 1 plus y plus c. Okay, so from this, what we can write, y is nothing but e power x minus 1 and 1 plus y is nothing but e power x plus c. So when you split, so again e power x gets cancelled. So 1 minus 1 by e power x plus c. So ln of 1 minus e power minus x plus c. This is also another method. So this is what you have got here. So this is another method we can also solve. Okay. Okay, we'll move on to the next problem. So, okay, this is another problem with integral with respect to exponential functions. This is termed as by-parts integration. So similar to the product of vu d differentiation of u into v, right? So similarly, integration of u into v. So that is termed as by-parts. So first we'll just learn what is multiplication rule in integration. So it is used, the concept is termed as I late. Okay. So this I stands for inverse trigonometric functions, L stands for logarithmic functions, and A stands for algebraic functions, T stands for trigonometric functions, E stands for exponential functions. Based on this rule, you will just determine U and V. Okay. So integral, this is a formula to be remembered. So integral UV is equal to U integral V with respect to dV minus whole integral u dash. Okay, differential term of the u dash. So u in that within that integral itself, you will have this integral v dv, same term here, with respect to du. You have to just solve this first and substitute that value, and you have to solve this remaining terms. Okay, so this u and v will be taken as based on this rule I late. Okay, so for example, we'll just look into this problem. Okay, so now based on seeing this problem, so we have an first which one should be taken as u and which one to be taken as v. Okay, so first, like let us take, like, this x is in algebraic function. So first algebraic functions comes in this I late. Okay, so first algebraic function, and then we have an exponential function. So first a comes, then after e comes. So a should be taken as an u. Okay, so which is nothing but x, and v should be taken as the last term, so exponential function. So u will be x and v will be e power minus ax. Okay, so based on that, when we substitute this in this equation, when on solving this equation, so a square term we have it outside, so we have here. So when we substitute that u here x, so v will be e power minus ax. So again, so differentiation of x will be 1, and integral v dv will be integral minus ax dx, and with respect to dx 0 to infinity, because they have given here 0 to infinity. Okay, so 0 to infinity. So when you go for it, so when you have to solve after substitution. So when you solve, this x will be remaining aside. So e power minus ax integration. So same thing, e power x integration will be e power x. So e power minus ax integration will be minus e power ax by a, because we have to again we have this minus a power x. Sorry, e power minus ax. Okay, so that will become by a. So plus 1 by a. Okay, why plus 1 by a, why it comes, because this value, this minus we are substituting here, so this 1 by a comes here, minus into minus becomes plus. Okay, so the remaining term will be minus e power ax, so dx. So again you have to integrate this part. So when you integrate this part, again same value, so you get minus e power ax by a. So this already 1 by a remains, so 1 by a into 1 by a will give you a square. So now this is a term. So now solve this and apply limits. So just multiply, so multiply this a square inside. So when you multiply that, so this a square and 1a gets cancelled, a square gets cancelled. So minus x into e power ax into a minus e power ax. Okay, so now apply the limits. So now when you apply the limits, when you apply infinity, sorry, when you substitute infinity here, e power minus infinity will be 0. Okay, so this becomes 0, these two. So when you apply when you substitute 0 here, so this when you substitute 0 here, here we have an x term, so this term will become 0 again. So here when you have substitute 0, e power 0, which is nothing but 1, sorry, 1, yeah, minus 1 here. So again when you substitute upper limit minus lower limit, you will get, so minus into minus 1, so you get plus 1. So that's why we get plus 1. So this will be your answer. Okay, if you have any doubts, you can just ask me. This is on one more method. Okay, then hope you guys are clear. Then we will move on to the next problem. So derivative of mod x. Okay, so with respect to x when x not equal to 0. So this is a direct identity which we have seen the second problem, if I'm not wrong. So differentiation of mod x is nothing but mod x by x or x by mod x, for which when x greater than 0, the value will be 1. Then x less than 0, the value will be minus 1. So directly mod x by x, f dash x is equal to. So that's what we have got it here. Okay, I hope this is a direct question. So we'll move on to the next question. So even function, odd function. So first let us discuss about what is an even function, what is an odd function. So let us take a function f of x. Okay, for a function f of x belongs to minus a to a. So let us take differentiation between odd function and even function. F of x will be equal to minus f of x when a function is said to be odd function. Okay, so then the function is said to be odd function. When f of x is equal, when f of minus x is equal to again f of x, it is said to be an even function. Okay, so for example, sin x, cos x, x and x cube. So when you have sin of minus x, which will be minus sin x. So again, when you have this here minus will get. So x cube minus, when you replace x with minus x here, again you'll get minus x cube. But here cos x, cos of minus x will be cos x, and secant of minus x will be secant x, x square. So when you replace x with minus x, again you'll get x square. Okay, so these are example. Then in terms of integration, so when it is minus a to a, f of x dx, when a function is said to be an odd function, the value will be 0. Okay, when it's same thing, when minus a to a, when a function is said to be even function, you can just replace this limit and write it as 2 into 0 to a f of x dx. Okay, then So therefore, from these options, we can tell f of x is equal to f of minus x, that is an even function. Okay. Hope you guys are clear. This is a direct question. So we'll move on to the next question. So improper integral. Okay. So from this, we have two methods. So first method, I'll just explain directly. So this is an integral we have. So integration of minus infinity to infinity dx by 1 plus x square. So directly f of x is equal to minus 1 by 1 plus x square. So then let's take f of minus x. So when you take f of minus x, replace x by minus x. Again, you will get 1 by 1 plus x square. So therefore, f of x is equal to f of minus x. So f of x is an even function. So what you can write this integral as? So minus infinity to infinity. You can write it as I is equal to 2 into 0 to infinity by 1 plus x square into dx. Okay. So this 1 by 1 plus x square integral is nothing but tan inverse x. So directly substitute tan inverse x 0 to infinity, and substitute the tan inverse infinity will be pi by 2, minus tan inverse 0 will be 0. So pi by 2 into pi by 2 will give you pi. I is equal to pi. So this will be your answer. Or what you can do is the same substitution method which we have followed earlier. So directly take x is equal to tan theta, because you know 1 plus tan square theta is nothing but secant square theta. So again, so 1 by secant square theta, you can just replace and we can find it out. So I'm taking x is a tan theta and theta is tan inverse x. So directly, so dx is equal to secant square theta d theta. So from that, so dx, so secant square theta into d theta by 1 plus tan square theta. So 1 plus tan square theta is nothing but secant square theta. So secant square theta gets cancelled out. So theta minus infinity to infinity, just theta is nothing but tan inverse x, which we have replaced it. So tan inverse x, substitute infinity and minus infinity. So tan inverse infinity is pi by 2, tan inverse minus infinity is minus pi by 2. So pi by 2 plus pi by 2 will get pi. So this is another method. That's all. Okay. Let's move on to the next question. This is the last problem of this. So number of roots of polynomial. So what they have given us, p of s is equal to s cube plus a2 into s square plus a1 into s plus a naught. Okay. So these all are real coefficients. What they have told us, p dash of x has no real roots. Okay. So first let us find p dash of s. So which is nothing but 3s square plus 2s a2 plus a1. Okay. So to find whether a function contains a maxima or minima, or like when it is when it has and roots. So what we do is, let us take a graph here. So let us take, this is the curve here. Okay, let us take, this is the curve here. Curve for and wait. So for a cubical equation, this will be the curve. Okay. So when there is this is a cubic equation, it has to be like it should have 3 roots. So how many times it cuts the axis, you will have that much roots. So 1, 2, 3. This is a standard cubic equation. But what they have said is, so here we have one maxima and one minima. Okay. But what they have, this minima and maxima, how you will find it out? By differentiating the first derivative and finding its critical points. But what they are telling us, well, after differentiation, this quadratic equation does not have real roots, which means it has an complex roots. Then the graph will be, sorry, then the graph won't have any maxima or minima, which doesn't have any critical points. So directly the graph will just cut one time like this. That's all. Okay. So then, which means what? So it has only one single root here. So one single root. So the number of real roots will be 1. That's all. Yes. So this is the last question of this calculus. Yeah, we'll have some 10-15 minutes break. We'll continue the class by 10:30. We'll continue the class by 10:30.
maybe after that some 45 minutes also,
Yeah, next we have differential equations, which are some 12 questions, and Laplace we have 8 questions. Hardly Laplace will take some 20 minutes, and this differential equations will have take some 30 minutes. That's all. We can complete it easier.
by 11:30.
Yeah, by 11:30 we can just complete. Okay. Thank you. You can just go for a break and return by 10:30.
Yeah.
Ah.
So you also do try to do as much problems. Okay, I'm also working. Okay, these are all simply the past our material available in our what is it the max textual course. Okay, yeah, it's like that. I'm also working for at least the last week I could work on problems on matrices from the other gate questions. So it's like that. I'm also working. Maybe I'll give you a kind of a summary class in sometime in the next month. Okay, that will be a part of this fast track classes. So at least a fast track class contents for always fast track max class I will take. Now I am also learning along with you people. Okay, thank you.
ஒன்றும் பிரச்சனை சார், நீங்க வச்சுக்கோங்க சார், ஒன்றும் பிரச்சனை இல்லை, நான் இது ஒன்றும் பிரச்சனை இல்லை. Okay, so that's okay, guys. Like it's time. So we'll start with the next topic, which is differential equations. Okay, so this is comparatively easier than calculus, so just simple. So the first problem. So what they have given here is the differential equation for the amount of salt X in a tank. So in a tank there is a salt amount of X with time t it's filling. Okay, so the variation is like it's filling. So with respect to the equation is dx by dt plus x by 20 is equal to 10x, which is in minutes. In kg, x is in kg and t is in minutes. Okay, so assuming that no salt initially, okay, in the tank, so there is no grams of no kilograms of salt, which is 0. The time in minutes at which the amount of salt increases to 100 kgs. So what they are asking, when it is increasing from 0 to 100, so 100 kg of salt, what is the time consumed? Okay, so first, so you have to just solve for t. Okay, so now write this equation. So just take dx by dt is equal to, take this x by 20 that side. So when you solve for that, so you'll get 200 minus x by 20. Okay, so 200 minus x in, yes, sorry, this is not x, so this is 10. Okay, so 200 minus x by 20. So take this 200 minus x this side, take this dt that side. Okay, so dx by 200 minus x is equal to dt by 20. Okay, so now integrate on both sides. So when integrating, x is salt. Okay, so for that what they have given, 0 to 100, initially 0, and in 100 to 100 they are asking. Okay, so it will be equal to 0 to t. Initial time is 0 and t is what we have to find it out. So dt by 20. So now when we are integrating, 1 by 200 minus x, which is nothing but log x. Sorry, ln x. Okay, so ln of 200 minus x. Since it is minus x here, you will have a minus term outside. So minus of ln of 200 minus x. So the limits are 0 to 100. Just substitute them. After substituting, what you get is, so when you substitute 100, you get ln 100, and when you substitute 0, you get ln 200. So multiply minus inside, so we get ln 200 minus ln 100. So when you're integrating dt by 20, 0 to t, so directly when you get t by 20. Okay, so when you substitute 0, so 0, you'll get 0. So directly substitute t, so t by 20. So this value will be equal to t by 20. So this can be written as ln of a minus b, ln of a by ln of a minus ln of b, which is nothing but ln of a by b. So ln of 200 by 100 is equal to t by 20. 200 by 100 is nothing but 2. So t is equal to, so bring this 20 here. So t is equal to 20 ln 2. 20 ln 2. Okay. Is that clear? Okay, I hope you guys are clear. We'll move on to the next problem. So this general solution of first order differential equation. Okay. So first, like the first order differential equation is dx by dy by dx is equal to x plus y minus 1 the whole square. Okay. So for this, how to start? So you have to find y here. Okay. So what you do is take this whole term as an substitute using substitution. Take this whole term as an one more term which is v. Okay. So this this one y plus x plus y minus 1 whole square will be v square. So that is what we hear. So that will be equal to dy by dx. Okay. So now differentiate this term. So dv by dx, because we want dy by dx here. So dv by dx is equal to differentiation of x will be 1, differentiation of y will be dy by dx, differentiation of minus 1 will be 0. Okay. So dv by dx will be equal to 1 plus dy by dx. Now you know what? dy by dx is nothing but v square. So bring it into some v square term here. Why? Because so you need dv by dx is equal to 1 by v square. So now you can solve the differential equation. So just bring this term here, then just take this dx here. So that is what we did it here. So now integrate both sides. So again, integration of 1 by 1 plus x square is nothing but tan inverse x. So tan inverse v will be equal to x plus c. C is nothing but constant term because we don't have any limits here. Okay. So plus c. So what is v here? So v is nothing but x plus y minus 1. So write x plus y minus 1. So this can be this tan, take this tan inverse this side. So which will be tan of x plus c. So x plus y minus 1 will be equal to, from this find y. So bring this to this side, bring this side. So y will be equal to tan of x plus c plus 1 minus x. So this will be your equation. Okay, which is this option. Option D. Okay, is that clear? If you have any doubts, you can just ask me. I'll give 2 seconds. Okay, we'll go to the next question. Okay, this is a fourth order differential equation. Okay, they're asking a general solution for this. So just write this differential equation like this. Okay, then take dy by dx as m. This is a common method using complementary function. We'll solve the differential equation. Okay, so just remember this how to start this method. So when you have this like this equation, differential equation, take dy by dx is m. Okay, so then what you'll get, m power 4 plus 2m square plus 1. So for this, just factorize this. Okay, so when you factorize this, you will get m square plus 1 the whole square will be equal to 0. So what are the roots for this? M is equal to plus or minus I minus I because it has 4 roots. M power 4 this thing biquadratic equation. Okay, so now for when you have 4 roots and it's a complex number, it is when the roots are not real, this will be your complementary function. So you have to just remember this. So which is nothing but c1 plus c2x cos x, c3 plus c4x sin x. So this will be a complementary function. So you have to just remember that there's no other way. So from this directly you can just write this option. This is option. Okay. So we have like this. We have different other models also for complementary functions. We'll just look into the upcoming problems so that from that you can just learn what are the complementary functions for what type of roots. Okay. So moving on to the next problem. This is a second order differential equation. So same thing. So what we have to do? So take dx by dt as m. Okay. So when you take it as m square plus 10m plus 25. So now just solve for m. So m plus 5 whole square is equal to 0. So m will be minus 5 minus 5. So the roots are real and equal here. So for that the complementary function will be c1 plus c2 t into e power minus 5t. Okay, this phi a here a. Okay, I'll just write the general formula for it. Complementary function x is equal to c1 plus c2 here they have given t, so t I am taking it as t. So t into e power minus e power at. A is nothing but roots here. A or m, we'll go with m. So m is the root here. So m is nothing but -5. So just substitute that here. This is a general. This will be a general form. Okay. So this is one more type. Is that clear? If you have any doubts, you can just ask me.
But this is applicable when the m is of equal value, right?
Yeah, ms, the roots of this equation are real and equal. Okay. This will
Okay.
be the complementary function. Okay, just like see, compare the complementary functions with the corresponding roots, like whether it is real and equal, whether it is biquadratic, it has 4 roots equal, like or real, like just compare and just study so that you can remember the general form of it.
If they are not equal, what is that?
Sorry.
They are not equal.
So if they are not equal, you'll get x is equal to c1 into e power mt plus c2 into e power minus mt. So that we have an upcoming problem, so we'll just look into that. So okay, so we'll move on to the next problem. So now this is general simple question. So what they're asking the order and linearity of this equation. So of this equation, so for this, like how to find the order. So the highest differential term here, so which is nothing but d square y by dx square. So this is second order. So second order. So and this thing y should be the equation is linearly dependent because it is dependent in the term of y here in this term. So it is linearly also dependent. So it is second order and linear. Okay, so the dependent variable is y. That's what. So that's why we get linear in the second order. Okay.
Talking about cost. Sorry, the x term.
So no, x is different. So x is the with respect to term, but it is dependent with the term of y. So the dependent variable is here y. So we have an y term here and consisting of this equation. So the equation is said to be linear. Okay. So we'll move on to the next question. So this is based on linearity and degree of the equation. So when you have the highest order, so which is nothing but here d square y by dx square. So power of the term is said to be degree. So power of this term is nothing but 1. So the power of the degree will be first degree. So these both are possible. So and again the equation is dependent, linearly dependent because it has a y term here. So again linearly dependent. So option is B, linear differential equation with the first degree. Okay, I hope you guys are like clear with this. We'll move on to based on differential equation. Theoretically, we have 3 types: order, degree, and linearity. Okay, so these are the theoretical questions they can ask. So moving on to the next question. So what they have given us, the differential equation is d square y by dx square minus 4y is equal to 0. A and B are arbitrary constants to this equation they have said this. Okay. So same thing, what we have to do, dy by dx as m. So m minus 4, excuse me. So m minus 4, which is nothing but the roots are plus minus 2. So plus or minus 2. So the roots are equal, the roots are real and distinct. So the distinct roots, for that, like we'll have this equation as I said earlier. So for this, the general form will be y is equal to c1 into e power mx plus c2 into e power minus mx. This is a general form of this is the complementary function for general form when the roots are real and distinct. Okay. So now we have got the complementary function as this. Okay. Now what they have asked is we have to solve this equation to this. We have to eliminate. They have given the arbitrary constants are a and b. So we have to take c1 is equal to a plus b by 2 and c2 will be a minus b by 2. Okay. So this is an case we have to take it like that. Okay. So when we take that, so just substitute c1 here, substitute c2 here. Okay. So when you substitute here, so solve for a and b coefficients. Okay, it should be in a and b coefficients because we have here coefficients. Okay, so you have to convert in either this forms. Okay, here. So when you solve for that, so take a common, so you get e power 2x minus plus e power minus 2x by 2, e power 2x minus e power minus 2x by 2. So e power 2x plus e power minus 2x by 2 is nothing but cos hx. Okay, cos h 2x because x is here too. So directly cos h2x. Similarly, e power 2x minus e power minus 2x by 2 is nothing but sin h2x. So sin h2x. So directly y is equal to a into cos h2x sin h2x plus b into. This will be your option. Is that clear? Like if you have any doubts, you can just ask me. Okay then. I hope you guys are clear. Yes, sir. Sir, actually, this is an formulas to be remembered. Cos. No, yeah, this is the formula. Cos hx is equal to e power x plus e power minus x by 2. Sin hx is equal to e power x minus e power x by 2. So this is an identity. So this is a formula. So we are converting this to this cos hx sin hx. That's why. Okay then. And I hope like it's clear for everyone. Then we'll move on to the next question. So which one of the following is not a solution for this differential equation? Okay, so first let us find this from options. We'll go. Okay, so from options what we'll do is, so y is equal to 1. So when you find dy by dx, just substitute like in this equation. Okay, so dy by dx will be 1 here. Just a minute. Yeah, that's what dy by dx is 1. D square by dx square is nothing but 0. Wait a minute. Yes, wait. This is not 1. This is 0. Okay, so dy by dx is 0 and d square y by dx square is 0. Okay, so again, so what you'll get, just substitute d square by d square by d square y by dx square, which is 0 plus y, which is 1. You'll get 1. Okay, so this may be a solution for this equation. They're asking which is not in solution. So moving on to the next question, which is y is equal to 1 plus cos x. So differentiate that equation. So dy by dx. So dy by dx when we do, so this will become 0. So cos x differentiation is minus sin x. Again double differentiation. So sin x differentiation is cos x. So minus cos x, you substitute it here, plus y. So y is nothing but 1 plus cos x. So cos x gets cancelled. So 1 is equal to 1. So this can also be the solution. So moving on to the next option, which is y is equal to 1 plus sin x. So when you differentiate here, so again 1, 0, differentiation of 1. Differentiation of sin x will be, sorry, not 0. Differentiation of sin x is cos x. So dy by dx is cos x. D square by dx square is nothing but minus sin x. So substitute it. So minus sin x plus 1 plus sin x. Sin x gets cancelled. So 1 is equal to 1. So option C can also be possible. So therefore the left out option is D. So that will be your answer. We'll just solve for sure, making it sure. So y is equal to 2 plus sin x plus cos x. So dy by dx is equal to, so this will become 0. The sin x is nothing but differentiation cos x. Cos x differentiation is minus sin x. So dy by dx is nothing but cos x minus sin x. Again differentiate this. So you'll get minus sin x minus cos x. So double differentiation of it. So just add these two. So this gets cancelled. So value will be 2. So 2 is not equal to 1. So this is not a solution. So this will be the answer for you. Is that clear? If you have any doubts, you can just ask me. Okay, then we'll move on to the next question. The differential equation is given as dy by dx y square plus x, y square by x plus y by x minus 2 by x. Okay, so dy by dx is equal to 1 by x. So just take x common. So 1 by x into y square plus y minus 2. So now take this term this side, this term this side. So now integrate this. Okay. So when you integrate this, you have this, as I said, like in previous calculus part, you have to split this term. So factorize this, try factorizing it. So y plus 2 and y minus 1. Okay. So when you do y plus 2 and y minus 1, so directly integrate it. So you have by partial fractions method, you can write it as y 1 by y minus 1 minus 1 by y plus 2. Because when you solve that, see, y plus 2 minus y plus 1 by y minus 1 into y plus 2. So this y gets cancelled. 2 minus 1, sorry. Here, yeah, 2 plus 1 will be 3. So here you will get 3. So when you multiply by 1 by 3, so you can just split this term as this. So 1 by y minus 1 minus 1 by y plus 2. So that is what we have got it here. So by partial fractions, we are just splitting the equation. Okay. So when you split it, so directly when you split, after just splitting it, just directly you can just integrate this term. So when you integrate, so 1 by 3 will be just common. So integration of 1 by y minus 1 will be ln of y minus 1. Again, integration of 1 by y plus 2 is ln of y plus 2. So ln a minus ln b, which is ln a by b. So ln of y minus 1 by y plus 2. So simultaneously integrate the right side part also. 1 by x integration is ln x plus ln c1. Ln c1 is also a constant, so I am taking it as ln c1. So when you take ln c1, so this is ln a plus ln b, so which can be written as ln ab. So similarly, so 1 by 3, take this 3 that side. So 3 into ln of x into c1. Okay. So now what we can write it as? So a ln b can be written as ln of b power a. Okay. So that is what we have written it here. Where here. So bring this will become a power term. So this ln terms, ln of what you get is, so you get, so ln of y minus 1 by y plus 2 is equal to ln of xc1 whole cube based on the property. Okay. So from this directly inside terms will get equal directly. You can just equal. Now the ln just gets removed. So y minus 1 by y plus 2 is equal to x cube into c1 cube. Now take c1 cube as c2. Okay, just to keep it as a constant term directly, no need of any pass. So I'll take it as c2. So when you take it as c2, so directly solve for y. Okay. So when you solve for y, so you get this equation. Y is equal to 1 plus 2 into c2 x cube by 1 minus c2 into x cube. Okay. Now take c2 common. Okay. Why? Because the coefficient terms doesn't contain c here. So directly take c2 common. So when you take c2 common, we get here 1 by c2, 1 by c2. So take 1 by c2 as an one more constant, capital C. So the c is equal to, so c plus y is equal to c plus 2x cube by c minus x cube. So c plus 2x, this will be an option. Yes. So nothing much. See, same thing. We are using the partial fractions method. Then by using log properties, we are finding equation for y, and then just changing c values, taking c1 cube is equal to c2, and again, since there's no constant term before x here in the options, you have to take c2 common. So here you get 1 by c2, that you are taking it as one more constant. So directly see, this will be an option. Okay. Is that clear? If you have any doubts, you can just ask me.
When is to include integrating constant? Since the answer has integrating constant, we are putting
Yes,
here.
yes. See, no, you have to include the integration constant every time, because this is not a definite integral to have some limits. This is an indefinite integral. Okay. So when you integrate this, when you integrate any indefinite integral, you should have a constant term. Okay. That's all.
Okay.
Yeah. Okay. we'll move on to the next problem. So which is like the differential equation is given as dx square d square y by dx square plus a into dy by dx plus by is equal to 0. So for that, what they have given us, the complementary function itself, they have given it as c1 plus c2 into x into e power mx. Okay, so as c1 and c2 are constant of this integration. So by seeing this, what we can tell is this complementary function comes when the roots are real and equal. Okay, so when the roots are real and equal, so when the roots are real and equal, so we'll just find the write the equation. So just m square plus am plus b. Okay, so that is what given here. So just write dy by dx is equal to m. So just write this. So the roots are real and equal. So for finding this roots, just do minus b plus or minus square root of this thing. So when you do that, which is nothing but minus a plus or minus square root of a square minus 4b, okay, by 2. So what they have told, the roots are real and equal. The roots are real and equal, then the delta should be equal to 0. So which is nothing but a square minus 4b should be equal to 0. So then a square is equal to 4b. So this will be an answer. This is one condition. Okay, is that clear? If you have any doubts, you can just ask me. Okay, then good. We'll go for the next question. Then we have to find this in one more model. This model is known as like linear differential equation. This is a new method. Okay, so when you have dy by dx plus y the plus p of x into y is equal to q of x. Okay, this is q of x. Q of x and function. Okay, so its integrating factor will be e power integral p of x dx. That will be an integrating factor. So by what they're asking this the integrating factor. So just directly do my integrating factor, which is one comparing this, p of x will be minus 1 by 1 plus x. So directly substitute that, integrate that. So minus 1 by 1 plus x, integral will be minus ln of 1 plus x. So e power minus ln of 1 plus x can be written as this minus can be written as 1 plus x the whole power minus 1. So that can be written as ln of 1 by 1 plus x. So e power ln x will be x. Okay, so directly, so our integrating factor will be 1 by 1 plus x. Okay, so this is finding an integral factor. Okay, for finding the solution, so what you'll do is, so that formula for the solving, so for that formula is e power is nothing but if. Okay, using this formula, you will solve for y and just get the solution of this equation. But they since they have asked for integrating factor, we have stopped here itself. Okay, this is the formula for that. So this will be our answer. So if you have any doubts, you can just ask me. Okay, I hope like you guys doesn't have any doubt. So like we'll move on to the next question. This is nothing but the solution of second order differential equations. They're asking with the initial conditions, y is equal to y of x, y of 0 is equal to 5 and y of 0 is equal to 10. So they have given d square y by dx square plus y is equal to 0. So directly first find the complementary function. So when you find the complementary function, take dy by dx is equal to m. So m square plus 1 so is equal to 0. So directly what we get, m is equal to plus or minus I. So this is like complex function. These are not real and these are not real. So for that, the complementary function will be when for m is equal to alpha plus I beta. When the roots are complex functions, so this will be the complementary function for the differential equation, which is y is equal to e power alpha x into c1 cos beta x plus c2 sin beta x. So here alpha is 0 because we have only imaginary term. So directly this term will be 0. So C1 cos x, because beta coefficient of I is nothing but 1. So cos x plus C2 sin x. So directly write it as. So now what you should do is, they're asking the solution directly with for finding constants. What they have given, y of 0 is equal to 5 and y dash of 0 is equal to 10. So directly, so y of 0 is equal to 5. So find the differential term for this. So minus C1, differentiation of cos x is minus sin x. So minus sin x. Differentiation of sin x is nothing but cos x. So dy by dx we have found. Y also we have found. So now substitute y of 0. Substitute 0 here. So what you get? Cos 0 is 1 plus sin 0 will be 0. So directly you get C1 is equal to 5. Okay. Then now y dash x. So y dash of x we have found it as here minus C1 sin x plus C2 cos x. So substitute 0 here. So when you substitute 0 here, this term becomes 0. This will become 1. So on solving, you get C2 is equal to 10. So directly substitute C1 and C2 here. So directly y will be 5 cos x plus 10 sin x. So this will be your option D. See, when they have given you some conditions like this, y of 0 is equal to 5, y dash of 0 is equal to 10, then you must be known that like you have to find the integral constants for this differential equation and find the answer. Okay. If you have any doubts, you can just ask me. Okay, then we'll move on to the. Okay, that's all. That's all for the differential equations. Then we'll have some 5 minutes break and we'll just continue for Laplace transform. We can just finish it off in 15 to 20 minutes. Okay. We'll return back by 11:05. Okay. Okay, then we'll move to the last chapter of today's class, which is nothing but Laplace transform. So this is pretty easy. You must have already studied in your process control. So we'll just this contains some different methods: shifting property and integration, Laplace integration, Laplace differentiation, and that's all. So we have some around 8 problems if I'm not wrong. So we'll just finish it off in another 15-20 minutes and we'll wind up the class. Okay. Then after that, if you have any doubts in previous class or today's class, we'll just discuss about that and just we'll finish today's class. So moving on to the first problem. So they're asking Laplace transform of e power at sin bt. Okay. So for that, so this is shifting property. So f of t is equal to sin bt. Let us take the f of t is equal to sin bt. So Laplace transform of f of t will be b by s square plus b square. Okay. So that will be the Laplace transform of sine function. So after this, when you take Laplace transform of e power at f of t, this is a shifting property where you have to shift s to s minus a. Okay, when e power at into some that function is there. So similarly, here we have an e power at into some function which is sin bt. So first write b by s square plus b square and shift s to s minus a. So replace s by s minus a. So this s will become s minus a the whole square. So b by s minus a the whole square plus b square. This will be the Laplace transform of this function. Okay, is that clear? Like, I hope this is an easy problem. We'll go for the next problem. So Laplace transform of exponential, this will be an. So first, what they are asking is, from this you have to first prove this. So from this you have to find this and this. Okay. So from this, what is the thing? So Laplace transform of e power omega t. Okay. So generally Laplace transform of e power omega t is written as, in terms of integration, 0 to infinity e power minus st into e power omega t dt. Okay. So when you solve this, e power minus, so directly e power a into e power b will be e power a plus b. So based on that identity, you'll get e power minus of s minus w, sorry, s minus omega into t dt. So now again e power minus at integration. So integration of that will become minus 1 by a into e power minus at. So minus 1 by a is s minus omega into e power minus at is e power minus s minus omega into t. Okay, so now substitute the limit 0 to infinity. So e power minus infinity, which is nothing but 1, we have 0. So we have seen last topics. So directly this will be 0. So first, like when you substitute, so that will be 1 minus 1 by s minus omega. When you substitute 0 in terms of t here, so directly this will become 1. Okay, so when you have minus 1 by, just a minute. So yeah, this will become 0 whole term. So because infinity, when you substitute infinity, so when you substitute 0 here, you'll have this will become 1. So here upper limit minus lower limit, so already 1 minus will be there. So minus into minus plus. So 1 by s minus omega. So you'll have proof here. So from this you have to prove sine h omega t is equal to e power omega t minus e power minus omega t by 2. So sine h omega t. So using that, what you write as, so from this apply Laplace transform on both sides. So when you apply Laplace transform, take 1 by 2 outside. So Laplace transform of e power omega t minus e power minus omega t. So now Laplace transform of e power omega t is nothing but 1 by s plus omega. So here replace, so just write this term here. Okay. So e power minus omega t will be s plus omega. So 1 by 1 s plus omega, just substitute these and just solve for these. So when you solve, so this comes here, this cross multiply. So s plus omega minus, sorry, s minus omega minus s minus, just a minute actually. So e power omega t will be here minus, here plus. Now it is correct. So solve for this. So s plus omega minus s plus omega. So divided by, whole divided by s minus omega into s plus omega. So when you solve for this, s gets cancelled. Omega will become 2 omega. So 2 omega will get, so this 2 omega, this 2 and this 2 gets cancelled. So what you get is, so what you get finally is omega by s square minus y square, s square minus omega square, because a plus b into a minus b in the denominator. So this has been proved. So from b you have to find this. So what is s? So s can be s, sine x can be written as e power ix minus e power minus ix by 2i. Okay. So e power omega t can be written as e power I omega t minus e power minus I omega t by 2i. Okay. So now same way apply Laplace transform on both sides. So 1 by 2y is constant, it will come outside. So Laplace transform of e power I omega t is nothing but just take this I omega as and some term. So directly instead of omega here, you'll have I omega. So I omega. Similarly here also you'll have I omega. Again take LCM and solve. You'll get above numerator, you'll get 2y omega. So that 2y and 2y gets cancelled. So you'll have omega by s square plus omega square. So this is also proved. Okay, if you have any doubts, you can just ask me. Okay, then I hope it's clear. Then we'll move on to the next question. So for the time domain of the function, f of t is equal to t square they have given. So Laplace transform of an integral. So integration of 0 to t f of t dt. So we have to find the integration of this. So this is the formula for an Laplace transform of integral. Okay. So Laplace transform of integral 0 to t f of t dt will be f of s, capital F of s by s. Okay. So here for this function, what f of t is t square. So for this, so the f of s will be Laplace transform. F of s nothing but Laplace transform of that particular function. Okay. So capital F of s. So Laplace transform of that particular function here is t square. So Laplace transform of t square is nothing but t power n is nothing but n factorial by s power n plus 1, where n is equal to 1, 2, 3. Remember that n is equal to 1, 2, 3, which are natural numbers. So when you solve for n is equal to 2, you get f of s is equal to 2 by s cube. So 2 by s cube by s will give you 2 by s power 4. So that will be your answer. Okay, is that clear? If you have any doubts, I'll give some 5 seconds. You can just ask me. Okay, then I hope it's clear. We'll move on to the next problem. So the inverse Laplace transform of a function. So this is an inverse Laplace. So f of x is equal to 1 by s plus 1 by s. So what you have to do is, so f of s is equal to Laplace transform of f of t. So which is nothing but 1 by s into 1 plus s. We have to split. So as we did in partial fractions. So 1 by s by 1 minus 1 by s plus 1. So when you take LCM, you get this equation. So like we have split this into fractions. So after this, now we apply inverse Laplace. So inverse Laplace of 1 by s, which is nothing but e power omega t. So 1 by s plus s minus omega is nothing but e power omega t. So here omega is 0. So what you have? So e power t. So directly this will be 1. Laplace transform of this will be 1. So and again here omega is plus 1. So e power minus omega t you'll get. So omega is so here omega is minus. So e power omega t, here omega is minus 1. So directly e power minus t you'll get inverse Laplace of this. So directly 1 minus e power minus t. This will be your answer. Okay, is that clear? I hope this is like clear for everyone. Okay, we'll move on to the next problem, which is Laplace transform of f of t is equal to t into sine t. Okay, so this is nothing but, so when you do, we know Laplace transform of sine omega t is nothing but omega by s square plus omega square. Okay, so now they have given, we have the function as sine t. Okay, so sine t is omega is 1 here. So substitute omega is equal to 1. So Laplace transform of sine t is 1 by s square plus 1. So when you have, this is another identity of Laplace transform. So when this form t power n, Laplace transform of t power n into f of t, when you have in this forms, the value will be minus 1 whole power n into d power n dsn. So that times its derivative into Laplace transform of that particular, this function f of t. Okay, so now if you see t into sine t is in that form. So now what you do is, so t power n, so there t sine t, so t power n is 1. So n will be 1, so directly substitute here 1. So Laplace transform of sine t is nothing but 1 by s square plus 1. So this differentiation will be directly u by v. So u dash v minus v dash u by v square. So u dash, so directly first numerator differentiation is 0. So this term, whole term will become 0. So v dash, which is to s square plus 1. So this will be 0. So s square differentiation is nothing but 2s. So minus 2s by s square plus 1. So minus into minus plus. So directly 2s by s square plus 1 the whole square. So this will be your option. So Laplace transform of this function will be this one. Okay, if you have any doubts, I'll give some 5 seconds. You can just ask me. Okay, then I hope you guys are clear. Okay, we'll move on to the next question. So, which is Laplace transform of a function is, so initial and final value. There we have to find the initial and final values. So if a function is s plus 1 by s into s plus 2. Okay, so initial and final value. So when initial value of function in a lab, then f of t at t is equal to 0. So limit t tends to 0, f of t is equal to limit s tends to infinity, s into f of s. What is f of s? Laplace transform of that particular function, f of t. Okay, so this is the initial value formula, and for final value formula, so at t is equal to infinity, so limit tends to t tends to infinity, s tends to 0, you will get s into f of s. So these two will be equal. So this is an identity for final value theorem. Okay, so now what we do is, so we'll find first s into f of s. So first we'll find the initial and final values. So we know f of s is equal to s plus 1 by s into s plus 2. So from this you want s into f of s to for finding final value. So take this term that side. So s into f of s is nothing but s plus 1 s plus 1 by s plus 2. So what you know is limit f of t tends to 0, limit s tends to infinity, s into f of s is so directly what you do is, so s tends to infinity here. So when s tends to infinity, we have again limits property is the L'Hospital infinity by infinity. So you have to do L'Hospital rule. So when you do L'Hospital rule, differentiating this numerator term separately, denominator term separately, you get directly 1 and 1. That's all. So the initial value of the thing first, this Laplace is 1, and again final value. What final value, for final value you have to just for s tends to 0. So when you substitute 0 in terms of s, it's not 0 by 0 or infinity by infinity, directly you get the value, so no need of L'Hospital. So directly the final value will be 1 by 2. That's all. So initial value is 1 and final value is 1 by 2. So 1 and 1 by 2. That's all. This will be answer. Okay, I hope you guys are clear. We'll move on to the next question, which is the last question if I'm not, no, one more we have. So the Laplace transform of function f of t is given as 1 by root of t. Okay, this can be written as t power minus 1 by 2. So when this here n is less than 0. Okay, so when it is n is greater than 0 or n is a natural number, you can directly write t power s by t power n by n plus 1 factorial. Okay, n factorial by t power n, s plus n plus 1. So here we have written the formula where it is. So this will be a formula n factorial by s plus n, s power n plus 1. But here n is not an natural number. So here it is 1 by 2. So when n is greater than minus 1, that is like 1 by 2. So you have to, when you apply Laplace transform, the value will be gamma. This symbol is known as gamma. So gamma function of n plus 1 by s power n plus 1. Okay. So f of s is equal to, so gamma function, so n is equal to minus 0.5. So minus 0.5. So gamma of 0.5 will be gamma of 0.5 by s power n plus 1, where s power 0.5. So gamma of 0.5 will be root pi. Okay. So directly you have to remember gamma of 0.5. There's nothing, no other way. So gamma of 0.5 will be root pi. So directly root pi by root s. So directly f of s will be square root of root pi by s. Okay, this will be your answer. Okay, there's no other way, so because like you have to remember gamma of 0.5. Most probably like this problem you will have the same problem or you won't have this problem. Okay, so that's all based on this problem. If you have any doubts, you can just ask me. Okay, then you're good with this, I guess. So we'll move on to the next problem. So Laplace transform of t into f of t is the same method. So here 1 by s square plus s plus 1, this is the Laplace transform of f of t they have given. So we have to find t into f of t's Laplace transform, same formula which we have used before. So what we do is, we know Laplace transform of this function is this. So t power 1. So directly 1 minus 1 power 1. So directly 1. So differentiation, they have given Laplace transform of the function is this 1 by s square plus s plus 1. So directly differentiate this term. So when you differentiate u dash v minus v dash u by v square. So same thing, numerator differentiation is 0. So this term, whole term will become 0. So minus differentiation of denominator, which is nothing but 2s plus 1. So 2s plus 1. So directly minus into minus plus. So plus 2s plus 1 by s square plus s plus 1 the whole square. That's all. That's all we have with
One doubt from
Laplace transform. Yes, sir.
calculus. Student asked.
Yeah, okay. That's all. So that's all we have this from this Laplace transform. If you have anything from this problem, you can ask me any doubts. Okay, then I hope you guys are clear. There's a doubt from one student from our class, like from differential calculus. I just discussed that problem. Yes. Okay then. Yes. So the doubt was, see this problem, like why we take cos x is equal to a cos x. Okay, what they have asked is they have asked the coefficient of x square here. So when you take this function directly as cos square x, this term will become directly this this term will become cos square x. Okay, so directly what they are asking here, so they are asking the coefficient of x. Okay, x, not cos x. Okay, when you take the function directly as cos x, so the Taylor series will be for cos x expansion, which is totally different away from the problem. Okay, so when you take cos x or when you take cos square x, so directly what you get is cos square x when you take, wait, so cos square x when you take that, so here what we become is what will be is cos square x, so f of cos square x, so f of 0, again here what we get is here again cos square x, wait a minute. Yes, actually we can do in that method also. So what we can take is, let us take cos square x, 1 minute, cos square x. Yes, this is what happened. 1 minute. So when we take cos square x, what happens is, so for example, as the student asked, let us take here cos square x. So when we take cos square x, so we need the coefficient of x square term here, which is nothing but f double dash of 0. So you have to find the double derivative. So when you do first derivative itself, what you get is, so f dash of x when you do it, so you'll get directly 2 cos x. Again, differentiation of cos x will be minus sin x. Okay, so which is nothing but, wait a minute, I'll just solve below. So differentiation of cos square x will become 2 cos x into cos x derivation is sin x, so minus sin x. Now what you do, when you substitute f dash of 0, so again what you will get is 0. Okay, that is not a problem. So when you go for again double derivative of cos square x, so what you get is differentiation of this term. So when you differentiate this term, so what you get, minus 2 into u dash v, so u dash v plus v dash u, so minus 2 into cos x differentiation is again sin x minus cos sin x, so you get 2 sin square x plus, sorry my bad, minus, again minus 2 cos x is there. Now different keep minus 2 cos x as it is and differentiate sin x, you'll get sin x when differentiate from sin x is cos x, so cos x into cos x, cos square x, so minus 2 cos square x. Okay, so now when you substitute f double dash of this, what you'll get is, so this will become 0, this will become minus 2. It's nothing but minus 2. So same thing, that's all. So minus 2. Yeah, we can take both methods. See, we either you can take cos square x is equal to cos square x, or x is equal to x cos x. Okay, so if you take cos square x, the differentiation will be just complex, that's all. So you have to do u dash v uv differential rule, then again find f dash of 0 and f double dash of 0. So since to make it easier, I have taken x is equal to cos x. So when you take when you take f of x is equal to cos square x, so f double dash of 0 we get minus 2. Same thing we have got it here. So based on this, so what we get, f double dash of 0 is minus 2 by 2 factorial, so which is nothing but minus 1, that's all. Same answer we get.
This ask is for cos square x, right?
No, they are asking, see, cos x, sir has asked me, they have asked for cos x. That is not, see, it is irrespective of the cos x. What they are asking is the coefficient of cos square x term. Sorry, maybe. Cos square x term. 1 minute. Taylor series of cos square x. Oh, okay. So you were asking like for cos square x Taylor's expansion. Okay, in that way, Actually, yes. This is the correct method, if I'm not wrong. Yes.
Okay, this corrected thing will update.
Yeah. Okay. See.
Not a problem. You take time and we'll.
Yeah. Okay. I'll just finally explain one time. So 1 minute. So I'll just explain this problem once again. So here they have asked for us for cos square x. Okay, but when I explained before, I've taken x is equal to cos x. So since they have asked for cos square x, you should take cos square x directly. Okay, x is equal to cos square x. So they are asking now, like since it is cos square x expansion, so for this you have to take x square coefficient, which is nothing but f double dash of 0 by 2 factorial. So now f double dash of 0 by 2 factorial will be minus 2 by 2 factorial. Okay, so which is nothing but minus 1. Now it will be correct. So when you have to just take, so if here f dash of 0, so f dash of 0 will be, so first we will find f dash of x, which is nothing but 2 cos x minus sin x. Okay, then again its double derivative will be 2 sine square x minus 2 cos square x. Okay, so from this f dash of 0 will be again 0. F double dash of 0 is minus 2. So from this here, minus 2 by 2 factorial. So we get 1. So if we get 1, I'll just solve for it. So this is the answer. I hope now it is clear for this question, regarding this question. If you have any other doubts, we can just, based on like today's class or last class, you can just ask me. We'll have some 2 minutes. Or like, you can just text sir and you can just notify me. Okay then.
Thanks.
Okay, then that's all for today's class. Like, and we'll wind up. Then sir, over to sir.
Yeah.
Okay.
Okay, we'll meet next week, and yeah, of course, we also have classes on Monday, Wednesday, Friday. Our the revision classes, no, our thermo classes is there in the coming week. Okay, I expect every one of you to be available in this revision class also, because at least you will be having a fast revision of the content. No, we also take up a good number of problems. Okay, more than all, I suggest you to take, I ask you to take this test regularly. So then only I will also get to know that you are also in track. Please do that. Thank you. We'll meet on Monday. Thank you. Thanks. Sir. Well, opportunity.
Sure.